And welcome to our Fields and Features segment, looking at space weather more in depth. We don't like to be shallow, we like to be deep. So here's 4 hours of magnetohydrodynamic pressure in the Earth space environment. Out to about 12 Earth diameters, this is what you could expect the magnetohydrodynamic pressure to be over the past 4 hours. This data courtesy University of Michigan. It's the Geospace Magnetosphere movie. Next, ground magnetic perturbations, Earth's magnetic moment from space was the last frame. Here is Earth's magnetic moment from the ground in magnetic flux density or nanotesla. Things very, very calm as far as magnetism going at the moment. Not a lot of induced magnetism. We've got a pretty slow solar wind and weak solar activity in general. We'll get more in depth into it. Here's the GOES magnetometer over the past 3 days. Pretty smooth curves here in the GOES magnetometer. And Earth is just solidly in a North Pole current sheet here at the moment. You can see the North Pole current sheet there toward the left in green. South Pole current sheet shown in red. And based on current activity, we're not expecting any changes to this coming anytime soon. Keep in mind the magnetic environment can suddenly change with basically no warning. So this is the line of sight view, also showing the solar magnetogram. Look at all that magnetic activity on the Earth-facing portion of the disk. Looks nothing like a grand solar minimum. So next, looking at the coronal hole line of sight plot, it also shows you the sun's B field in blue. The blue lines there, the sun's B field. We showed you geospace delta B, Earth's B field, or changes in it from the ground level. Here is the sun's B field. Coronal holes there showing up in a trans-equatorial configuration, both in South and North Pole orientation. South Pole shown in red, North Pole shown in green. And we are expecting geomagnetic unrest in about 2.5 days from some coronal hole high-speed wind stream. Here's a great view of coronal holes in 193 angstroms from the SDO. One of the best wavelengths through which to view coronal holes. There are streams of protons being emitted from those. You could say solar jets. Solar plasma jets coming out of those coronal holes. Another great wavelength to view coronal holes is 211 angstroms. Shout out to Brett from Alaska. Hey, Brett from Anchorage, Alaska. We do viewer requests. If you've got a request, what would you like us to cover that perhaps we haven't been covering? Let us know in the comments. We even do requests on our meteorology segments, theoretically. So if you've got a specific report you'd like us to do, let us know in the comments and we'll consider it. Next, looking at flare probability, not all that high here. The most likely spot for a flare would be from sunspot 2948, in my opinion. It's a beta-gamma class sunspot group. Last night we were up to as many as 9 sunspot groups. Now we're at more like 6 or 7. Most of them have degraded here. Sunspot 2948 mostly has stayed stable, it looks like here. Actually, it's degraded a little bit too. So here's the last 24 hours in 1700 angstroms. It's great at showing sunspots when there are decent-sized ones, at least. And 2948 is the one to watch, in my opinion. See what happens next. And here we've added 171 angstroms to the 1700 angstroms view. These are all wavelengths of ultraviolet light, by the way, folks. These are not visible from the surface of the Earth. That's why we use the SDO to view these. Discovered in the early 70s at Skylab. The ultraviolet spectrum of the sun gives us all kinds of insight into what is going on with heliophysics. Specific chemical species showing up there. Next, looking at the X-ray flux here over the past 3 days. Only C-class intensifications over the past 24 hours. We did get some relativistic particles also, probably associated with this M-class flare. It took several hours for them to arrive. But in any case, there you can see a continued slight signal there in the proton flux, not enough to even cause any expected polar high-frequency radio blackouts. Next, looking at the real-time solar wind here, we're seeing a pretty weak solar wind speed. Solar wind speed here below 400 kilometers per second, only 377 kilometers per second, having reached a bottom of all the way down to 330. Current solar wind density, about 4.3 protons per cubic centimeter. The rest of those bars are fairly unremarkable. KP index at 1. No surprise that we're seeing geomagnetic calm conditions. How about a solar system forecast? Here's where stuff is now. Let's advance it 1 week. There's where things will be in a week. Mercury speeding away from Venus as Venus speeds away from Earth. You may get a great view of Mars, Venus, Mercury, and Saturn rising ahead of the Sun. If you've got a low horizon and you're up before dawn, go check it out. Send us some imagery. Do you have a telescope? Would you like to be featured on the Daily Space Weather videos? We'd be more than happy to show your content, so let us know in the comments about that, or drop us a line. All kinds of contact information on social media and so on. Look us up at smashomash.com. Also, the moon in a setting mode here in Lehigh Valley, Pennsylvania. This is from in-the-sky.org. Lastly, let's take a look at some coronagraphs. You never know when you'll see a sun-diving comet on the LASCO C3. We showed some yesterday. It was a double, probably a single comet that broke up based on their trajectories, which were nearly identical. Here's Stereo A here on the left. No CMEs to really report on. Stereo A is located at Lagrange 5, and the SOHO LASCO C3 is located here at Lagrange 1, if you were wondering. We're wondering what else you'd like us to cover. Let us know in the comments. Thanks for tuning in. May that solar wind be at your back, and I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news.